Hello, this is Paweł Biernacki. I'd like to show you today some examples from Perkun. Perkun is not a general purpose programming language. It is just a language for a very specific purpose, for replacing, so to say, if-then. If-then is a known construct from multiple programming languages, and I would like to discuss example 3, Pregor Perkun. Pregor is a character, it is an NPC, so non-player character from my game, which demonstrates how to use libperkun in your own projects. Let's take a look at the specification. In the specification, you can use comments, and here are 4 sections that have to be there. They are mandatory. One section is values, so you can put false, true, place Vizima, place Hadizar, place Novigrad. These are 3 places from the game. And then 4 actions. Do nothing, go to Vizima, go to Shadizar, go to Novigrad. Then you have variables. Variables are input variables, output variable, and one hidden variable. Input and output are self-explanatory. You can see that after each variable we have a number of possible values. It is illegal not to put any value at all. It makes also no sense. So you must have certain values that the variable may have. And there are 2 input variables. One is where is Pregor, and another one is do I see vampire. So does Pregor see vampire? And the output variable is the action that the Pregor can do. So do nothing, go to Vizima, go to Shadizar, go to Novigrad. And there's one hidden variable. Hidden variable is something that affects the world of the state of the world, but you don't see it, you don't perceive it directly. Still, it is very important. So where is vampire? It can be in one of the 3 places. Place Vizima, place Shadizar, place Novigrad. Then we have payoff function. Payoff is a function in the mathematical meaning of the term. So it is for each combination of the input variables. Here's such a combination, for example. We have certain number. This number must be 0 or positive. Unary minus is not supported. And it defines that if you don't see vampire, if do I see vampire is false, you have 100 points. If you do see vampire, you get 0, which means that the better number is this 100 points. It is a higher number. Therefore, it's better. It's considered better. Perkun tries to maximize the expected value of the payoff of this function that we have defined here. When we see another example, another NPC from the game, namely Dorban, we will see that his payoff is completely different, completely opposite to this one. But I'll show you later. Now the model, this is the 4th section. We may have definitions for illegal actions, but these are not mandatory. So if we don't want it to choose action go to Vizima when we are in Vizima, we can use it like that. This defines that the action is illegal. We also have definitions, not obligatory, for impossible states. And it says that, for example, if the vampire is in Vizima, then we must see him. So it's impossible not to see vampire when we are in Vizima, and the vampire is in Vizima. Okay, but the most common instructions are set instructions, and let me find one here, for example. Where is Pregor in Vizima? Do I see vampire false? Where is vampire Shadizar? So this is the initial situation. The action do nothing. Then the terminal situation and probability. And probability. Okay, as you can see, the model is huge, and I'll just go to the end. After the model, when the model ends, we have any number of simple commands, and we have one here which is loop with the parameters specifying the depth of the game tree, how deeply we go into the game tree. Okay, so now we're going to run this specification with Perkun. It takes a while. Okay, so it tells you I'm entering loop with depth 3, which reflects directly this parameter, and I expect the values of the variables where is Pregor and do I see vampire in this order. This order is meaningful because it reflects the order in which the values must be input to the session. Okay, so let's choose place Vizima, and we don't see vampire. Okay, the decision will be do nothing. As you can see, he prints out the belief. This is a belief, and the optimal action. And this is the purpose of Perkun, to choose the optimal action in the given situation and to print out the belief. The belief is something like a state. If you compare it to the if-then instruction known from multiple programming languages, the if-then does not have a state, does not have memory or attribute to remember its decision or to remember something that has been perceived, and this is a huge difference to Perkun. The belief is a probability distribution over a set of states. So this is one state, this is another state, and here is another state. Here. And you can see that the first state is impossible. Perkun has assigned it with probability 0, while the two other states are 50% probable. So the two other states is vampire is in Shadizar, vampire is in Novigrad. He is not in Vizima. We know that because we can't see him, and we are happy with that. We don't do anything, so we are staying all the time with Vizima and false. Do nothing. Okay. Now let's check how it behaves when we enter that we see vampire in Vizima. Now you can see a different belief, namely the vampire is in Vizima for 100%, of course. So the belief is an interpretation. Sometimes it is completely certain. It is an interpretation of the input, and it changes from one input to another. and it is very influential. It is very important for our decisions. He's decided now to go to Shadizar. If we type place Shadizar here, and obviously there will be false as do I see vampire, then the belief almost doesn't change. So of course the place where we are changes, and do I see vampire changes because they are two input variables that have changed. But the first possibility, where is vampire in Vizima, will still be true. So we will know that the vampire is in Vizima, and he is for certain not in Shadizar and for certain not in Novigrad. And once we got to Shadizar, we were happy with that. We choose to do nothing because the vampire is away and we don't like him, we want to avoid him. We will be just happy with that. So place Shadizar, false, do nothing, and so on. We'll continue doing do nothing. Okay. Now I would like to show you another specification, which is example 2, Dorban. And it differs actually only in the payoff. This is the most important difference between Dorban and Pregor. Pregor, as you remember, was someone who was avoiding vampire. Dorban is someone who's hunting him. He's a witcher. And therefore, you have the same values, almost the same variables. So there's where's Dorban instead of where's Pregor. But the same possible values and everything. And the payoff is different. Namely, for the false, do I see vampire false, we have 100, we have 0, and for the true, we have 100, which means we will always try to get there where the vampire is. We don't know where he is, not always know, but we will try to get there and stay where the vampire is. This is how Dorban works. Now also the section model, mandatory section. Here's an example of an impossible state. The set instructions that specify the transition probabilities. If you remember, like here for example, initial situation, action, terminal situation, and probability. Okay, so I'll go now to the end, and you will see that we also have one loop, one command loop with the parameter 3. And now we run this example with Perkun. Okay, similarly, we are entering a session, and the two parameters that it is expecting us to give is where is Dorban and do I see vampire. Place Vizima false. Let's assume the vampire is in somewhere else, so we don't see him. Now the belief is here, and the belief says that there is 50% chance for vampire to be in Shadizar and 50% for the vampire to be in Novigrad. And there are no chances that he is in Vizima because we are in Vizima and we don't see him. This was defined as an impossible state. So the decision is to go to Shadizar. Let's go to Shadizar. And let's assume we still don't see the vampire. Now, even though we haven't been to Novigrad yet, we can see that the Perkun is certain that the vampire must be there. We are in Shadizar, but we have been to Vizima and we have been to Shadizar, obviously. So we know the vampire must be in Novigrad. This is how the interpretation of the input values works in Perkun. So even though he goes to Novigrad, he knows already that the vampire will be there. So we obviously give true. Do nothing. So stay where you are. Now the belief has changed a little, so the input variable have changed both, but we still know that the vampire is in Novigrad. This didn't change, and the chosen action is do nothing. Now what happens if we do see vampire immediately? This is an easier case. Do nothing. Simply do nothing, because we know he obviously is there where we are when we can see him, and we don't have to do anything in order to get the optimal value of the payoff. Okay, so it was everything I wanted to show you about Perkun. Please take a look at Perkun Wars, take a look at the source code of the game, try to play it a little. It is generally not a good game. It is something to show how to use Perkun in your own programs. In how to use libperkun. It's a library that is compiled and built when you build Perkun. Okay, thank you very much for watching, and take a look at my other films.